Okay, so in the previous examples, we have provided you with some examples for the index tables, right? And you can see we create an index table and also put these entries in the index table in a sequential way. Therefore, this index table is also called a sequential index. It's more like a list, right, for storing these index entries. And then what's wrong with this sequential index? We mentioned before, right, we have always to maintain a solid sequential index table. So actually, it will create some problems. And of course, we have some advantages for this sequential index. It's relatively easy or fast to access. It's a list, right? However, we have some cons. It's very hard to maintain the sequential properties upon some updates, because we mentioned that this index table can keep updating as we have new queries to come in, right, to process. We have also need to update this index table accordingly for the new queries. It's very hard to maintain these sequential properties, as we have some insertion deletion of the entries here. Therefore, because of these problems, we have to propose a new data structure to maintain these index tables, which is called the B plus tree. The B plus tree intuition is to give up the sequentiality of the index and also try to get a balance of these dynamic organizations of the indexed entries as we run in the system to do the updates of the tables. And this B plus tree was proposed by the Professor Bayer, and he proposed a B plus tree, B tree, as well as red-black tree as well. Because of his contribution, he also received the ACM Sigma Electrical Code Innovation Award in 2001. Okay, so what is a B plus tree? I assume you have learned the trees in the data structure courses, right? As well as the discrete mathematics course, even in the algorithm courses. So if you have a background, it will be relatively easier for you to follow the materials in the following pages. So what is a tree? Tree is a data structure. In the tree, we have both these nodes and as well as edges, right? So normally for the B plus tree, we use these nodes for storing the data, and we use these edges denoting the pointers. Pointer can either point to some like branches, like children nodes, or pointing to some concrete data tuples. So in the B plus tree, we have an important parameter, which is called D, or the degree of the nodes. Whenever you create a B plus tree, you have to assign a value for D, this parameter. This parameter is very important because it controls the structure or the shape of the tree, of the B plus tree. According to the B plus tree definition, all the nodes should have some keys, and the number of keys allowed for the B plus tree has a range. The number of keys in each node should be in the range from D or 2D. You know this is a bracket, right? This is not a parenthesis, it's a bracket, so it includes D and 2D as well. We have an exception, except the roots. This root can have any number of keys in it. However, for the remaining nodes, either the leaf node or internal nodes, the number of keys inside it should be in the range from D to the 2D. This D is a value we assign for the parameters. And we'll provide you with an example for both the internal node in the B plus tree as well as the leaf node in the B plus tree. So the data structure for the nodes in the B plus tree is like this. Each node has two layers. The first level actually contains the keys. The second level denotes the pointers. Now in this example, for the internal node, we have a node with 3 keys, 30, 120, 240. You see the key numbers in the node, they are sorted from the left to the right. They are in an increasing order. Right. And in this one, we have three keys. However, we have 4 pointers. Each pointer has some concrete physical meanings. The left pointer points into the children nodes, and it also denotes a range, linear range, because it's a left pointer of this 30, right? Therefore, all the values in the children nodes for this pointer pointing to should be in a range from a number like x to the 30. Here it is the parentheses. And for this pointer is between 30 and 120, right? Therefore, all the numbers in the children nodes this pointer points to should be in the range from 30 to 120. This one is in the range from 120 and 240, and this one is from 240 to a certain number, which is larger than this number. You follow me, right? So the first layer denoting the keys, the second layer denoting these pointers. And for the children nodes, each pointer points to should be in a range for these values. Besides this internal node, we also have a diff node. Diff node is in a very similar structure as this internal node. However, for the pointers they pointing to, they are very different. Now this one we also have two layers. The first layer denoting the keys, the key values. The second layer denoting the pointers. The key values is very similar, some concrete values. They are also in increasing order from 30, from 40, 50 to 60. From the left to the right in an increasing order. However, for the pointers in a different node, they are very different. They are either pointing to some concrete tuples in the storage tables. This pointer points to a concrete tuple storing a record with such key value equals to 40. This one points to a tuple, concrete tuple, storing some data records with such key values equals to 50. This one points to a tuple with such key value equals to 60. Because this one is a different node, it points to some concrete data tuples. Also, the values for these entries or tuples, they are equals to the such keys. It's very different from here, right? Also, another difference is the last pointer. The rightmost pointer actually points to the next leaf node. In other words, the sibling node of this node. So you can follow me, right? For the internal node, it's pointer pointing to some children nodes. Because these children nodes, they are also denoting some value ranges, right? For the attributes. They are pointing to some children nodes denoting some ranges for the such value, right? Such key. The leaf node, they are pointing to some concrete tuples. And the value also matches or equals to such key, actually. It's not a range, it is equality, right? For to some tuples. Also, the rightmost point, they are pointing to the next leaf node. It's very different from here, right? Okay, so this is about some basic information about B plus tree.